can. You guys tell me if you can hear him.
What? Oh.
Let's see.
Just every time I come to Twitch, I have to figure out how to find where to do the pop-out chat.
Oh. Let's see. I think we got this. I have to adjust this every time too. I wish it was a static thing, but it's most certainly not. I change. I know. I change the window size all the time. It's my fault. So, it doesn't maintain.
It was so cool when you had that green screen.
I know, and the green screen would be way too hot in this room right now because this room is insanely. It would be way too hot. It would just not work out. This room gets, barely any air in it as is. And, combined with the humidity, it's no bueno.
Joe is saying, make sure that Google isn't alive.
What?
I don't know. Is Google alive?
Make sure Google isn't alive, Fraser.
Oh, I see. Oh, I know what he's saying.
What is he saying?
Hey, Google, when's the robot apocalypse?
Sorry, I don't know how to help with that yet.
Not yet, though.
Not yet.
Not yet.
But she does know how to help with it in the future.
Yes. Soon, yeah. TM.
Soon. Soon there will be a robot apocalypse.
Just you wait, guys.
Yeah.
So how was your week then?
I made a bunch of people's Google homes go crazy. So
I don't have Google. I have Alexa.
I'm a Canadian. And so as a Canadian, as second-class citizens, we couldn't get Alexas for the longest time. And I tried to figure out every single way that I could get a Alexa to work here in Canada. And in the end, I just said, you know what? It's not worth the energy and the effort. And then Google came up with theirs first, and so I went with that.
Oh, I see.
Yeah, like I was just allowed to get YouTube Red 2 days ago.
Oh, yeah. No, I don't even have that. I know people that do.
Really?
Yeah.
Oh, you don't watch any ads. I've got the family account, so the whole family doesn't have any ads and downloads music and can watch videos offline. So it's totally worth it for me.
Oh, yeah, no, I could see that too. Yeah, well, I don't think we get ads. But that's probably because I have ad block on. I'm not sure. I don't know.
Thank you.
I know. Well,
so
certain ones.
So that's why I don't make any money, any ad money from my videos.
Maybe. I don't know.
Yeah.
I can whitelist certain things, so I do.
So for you, if you're going to be showing videos,
I whitelist.
Having the YouTube Red would make a lot of sense.
Yeah, because I do show a lot. So, what about Cortana?
I turn that off as soon as I install a new Windows machine.
Yeah, same here. Cortana is silenced on my OS as well.
Yeah.
Sky, it is Thursday, not Friday. It's Thursday. I said it was Thursday in the tweet.
Thursday's my day.
Yeah, Thursday is Fraser Day. Yeah, everybody has days now. A Twitch streamer with ad block. Okay, so you can actually whitelist domains, and also you can whitelist certain channels and things. Like Twitch, I have completely whitelisted. Like that that won't be a thing. But I have Prime, so what does it matter? I don't get ads anyways. So,
right.
Yeah. So, what day is my day? Every day is Joe Day. It's all about sponsorship and product placement. Yeah, and it's also, if you watch someone's video too, like I like to source a lot of that stuff too, because that's important. But I was just talking about the dust storm in Mars and how that's kind of reached global proportions. Have you already read that today? You probably have.
Mm-hmm. Yeah.
That's crazy.
Yeah, well, I mean, these happen from time to time. Every few years, you get a dust storm on Mars that blots out the sun like this, covers the entire planet. The downside is that Mars is approaching its opposition right now. Well, it's two downsides, right? One is it may kill a rover, but the other downside is that Mars is approaching its opposition, so it's becoming the best time to see it. And so in July, Mars is going to be at its closest, essentially, to us in the sky, and we're going to get a chance to be able to see it really nicely. But because of the dust storm, all of its surface features will be really obscured. You won't be able to see the polar caps very well. You won't be able to see really any of the surface features. And then, as the dust storm fades, Mars will get farther away from us again. And so it's sort of it's a cruel trick, because it's one of the best. It is the best chance to see Mars since 2003.
Mm-hmm. Yeah, I think we know that these dust storms happen, but to this scale, I think like the last time was even before Curiosity was there, right?
There has never been a dust storm on Mars that's been this bad since we've been observing Mars.
Yeah. So like early 2000s.
This is the worst dust storm that has ever hit Mars in our ability to measure the dust storms on Mars.
Yeah.
And the darkness that it's causing on the surface of Mars is total. And for Opportunity, it's only getting, I think, 2 milliwatts of power to its solar panels. And that is not, it needs more to be able to survive.
So have they, is Opportunity just like in shutdown mode right now?
Mm-hmm. Yeah.
Trying to save that?
It's in total shutdown mode at this point. Hunker down, trying to keep, it has programs that they'll run in these kinds of situations for it to try and keep its electronics warm, try to keep its batteries as warm as possible for the duration of this storm. Mm-hmm. But if the batteries get too cold, if its electronics get too cold and it can't keep itself warm, then it'll be dead.
Yeah. Someone said, why aren't rovers wind powered?
That's a good question. The biggest problem is that the atmosphere on Mars is 1% the thickness that it is here on Earth. So imagine going out into a windstorm that was the same speed as a windstorm on Earth. Say you've got 50 kilometer per hour winds, or let's say 100 kilometer per hour winds. It would feel like 1 kilometer per hour winds, because essentially the volume of air that's being pushed against you is 1%. So winds can actually be very fast on Mars, and it's enough to get the dust up into the air, but it's not enough to really, you wouldn't feel it. You couldn't fly a kite. So that's the downside of Mars. And so you'd have a really hard time operating wind turbines in that low, but theoretically it's possible. And NASA is working on a helicopter that's going to be able to go to Mars. It's just going to spin at like 3,000 times a minute to be able to generate the lift to be able to fly around on Mars. So, it's not zero, it's just not great.
Yeah, and someone's asking if the windstorms cover the ice fields at the poles.
Well, the windstorms go across the whole planet, right?
Right.
It's the same thing as what happens here on Earth. You've got pressure differences, temperature differences, and these cause winds to go from place to place. And they can go anywhere. Wherever you've got temperature differences on Mars, you're going to get winds, and the poles everywhere.
Yeah. This article says the Martian dust storms are common, like we were just saying, especially in the southern hemisphere, spring and summer, when the planet is closest to the sun. And it says that as the atmosphere warms, winds generated by larger contrasts in the surface temperature at different locations mobilize dust particles the size of individual talcum powder grains. Carbon dioxide frozen on the winter polar caps evaporate, and thickening the atmosphere and increasing the surface pressure. That's interesting. Yeah. So it's it's kind of amazing that Mars has the same kinds of weather systems that we have here on Earth, but just the Martian version of it. So and these dust storms are relatively common, but these big planet-wide ones, they happen once every, say, 5 to 10 years. So the timing is, as I said, the timing is terrible. Best Mars in 15 years, and we get a global dust storm. Yeah. For people who hypothesized water having been on Mars, what is their theory for why it disappeared? Was it just blown away by solar winds?
Yeah. The solar wind is constantly blowing out of the sun, and this is the stream of charged particles that's coming from the sun, and it's buffeting the Earth, and it's buffeting Mars, and it's buffeting Jupiter. But the Earth is protected by this great big magnetic field, the magnetosphere, that stops the solar wind particles from directly impacting the atmosphere. Some of it does, but it protects us mostly, while Mars is too small and never sort of generated or does not have a proper magnetosphere to protect it from the solar wind. And so the particles, the water particles, were broken up, and the lightest particles, the hydrogen atoms, were blasted out into the solar system by the solar wind. So Mars is dry. Now, some of the water is still locked up in the polar ice caps, but a lot of its water was lost over billions of years thanks to the constant solar wind. And of course, even if we just smashed a bunch of comets into Mars and replenished its water supply, that solar wind would continue to grind away at it, and eventually you'd lose all that water too.
Yeah, because it has such a weak magnetosphere. And that's, like we were talking about, Magneto, X-Men confirmed.
Yeah.
Right, exactly. So someone said, Fraser, are you aware of the clouds that have been filmed going over Olympus Mons?
I would have to, is there a specific picture? I mean, I've definitely seen some cool cloud patterns around Olympus Mons, but I don't know of exactly what they're talking about. No. Is there some, do you have a link?
Yeah.
I'd love to see it.
If you have a link. Yeah, so so this does, someone just asked, so no larger debris is moved, and I said, that's correct. A lot of this is just dust, right? And I mean, it can be kicked up in the air, guys, and it can go up to 60 kilometers or something
and this
ridiculous.
Stuff, because the gravity is so low, right? So you've got this really low gravity on Mars, you've got this really high wind speed, and the particles are very small, and it's a perfect storm for creating these kinds of things.
And someone said, do the storms on Mars change the surface as much as that messes up what we've mapped out so far?
No, it doesn't change. I mean, it's what's shifting the dust around on the surface of Mars. Here on Earth, we've got water, wind, and plants that are resurfacing the planet, and I guess over vast periods of time changing the maps. But on Mars, they don't have the water and the plant life. They've just got the winds. And so the wind is scouring away at mountains and hillsides and canyons and turning things into sand. It creates sand dunes, and these sand dunes are pushed around. So a lot of the features seem very familiar, but they've only got wind and the occasional meteorite strike as a method of erosion on the surface of Mars.
Yeah. These are really good questions. You guys are, would water bears survive on Mars?
Water bears, no. They might be able to survive. Water bears are super tough, and they can go into a sort of state of suspended animation, and they could probably pull that off on Mars for a while. But they wouldn't sort of have a place they could return to. But there are methanogen bacteria that can survive on Mars right now, and could. I don't know if you call it thrive, but they could multiply and do their thing on Mars. If you've had some area with a little bit of water, like some kind of salty, briny sort of reservoir under the ground. Also, lichen on Earth are pretty close to being able to survive on Mars and do photosynthesis from the surface of Mars. So actually, there's a couple of life forms from Earth that are pretty much ready to go. Cyanobacteria is another one that you could take to Mars and start to generate oxygen if you wanted to. So there are some, there's some methods that you can right now today. And this is one of the issues, up until this point, scientists didn't think that there was much that you could take to Mars that could survive. And so they weren't that concerned about the planetary protection. And now you see that, oh, in fact, we have these life forms that are so tough that they actually maybe could survive on Mars. And chances are they are hitching a ride on board our spacecraft and going to Mars. And so scientists, NASA are trying to learn to be a lot more careful about the way they sort of clean off their spacecraft before they go to Mars.
Yeah, because you don't want that, start questioning the science of like, was this original here or did we bring it along with us?
I got I saw a couple of questions are just wanting to talk about an artificial magnetosphere. I don't know. Have you spent a lot of time talking about that on this?
No, and
channel?
I thought that was a great one for you to tackle.
Sure, yeah. So obviously, on Earth we've got our magnetosphere, and it's generated by the dynamo effect of the core of the Earth that's turning around inside. It's this metal ball that's spinning around inside the Earth. So Mars is a lot smaller and it cooled down, and so if it did have that in the past, it's long shut off. So the question is, can you create some kind of artificial magnetosphere? And the answer, well, there's sort of two plans for this that seem within our capabilities right now. One is that you set up a shield at the Sun Mars L1 Lagrange point, and that's this sort of gravitational balance between the Sun and Mars. Put this big shield there, and it would essentially block the particles coming off of the Sun, like I don't know, imagine like a rock in a river, right? And you can sort of see this sort of calm area behind the rock where the rapids are being kind of, the water's being stilled, right? And so you can imagine you'd have this shield, some kind of like big shield that's blocking the particles from the Sun, and Mars is in this shadow from the shield. And so now you wouldn't be getting that radiation coming from the Sun, and you would actually then be able to start recovering the atmosphere of Mars. So there's these volcanic emissions that are happening on Mars, and they would be putting out these particles that would be going into the atmosphere of Mars and thickening the atmosphere. And pretty naturally, over the course of a couple of decades, you would get the ice caps to start melting just by doing this. So if you just block that solar wind, you're going to get the atmosphere on Mars to thicken, and you're going to get the poles to melt a bit, and you're going to get some level of sort of warming, thickening atmosphere, which is pretty exciting.
Yeah.
So that's the sort of the way to do for the whole planet. But if you want to like go and take some Mars colonists and live on the surface of Mars, there's been a couple of ideas for this as well. And one is there are actually pockets of sort of mini magnetospheres on Mars. They're not great,
right?
But if you kind of go into them, you can get some sort of protection, better protection. But the other thing that you can do is you can build you build like a big torus. You essentially take a big donut and you build it into the ground on Mars, where the top part of the donut is just coming out of the surface of Mars, and it's big, like it's like a kilometer across, the whole donut. And it's a solenoid, it's a coil. And so you then run electricity through this coil, and that generates a big magnetic field. And so you would then put your colony under this magnetic field. You could do the same thing on the moon. Just build this big, almost like a cage, a donut cage.
A donut cage.
You would then be under, and you could of course put panels on top of this thing to make micrometeorite shelters, and you would then be able to be protected from sort of the wind coming from the Sun, as well as the occasional solar flares, and even the galactic cosmic radiation, which is pretty dangerous. But in the short term, the plan is go live in a lava tube.
Yeah. Yep. That's the short-term plan. And because I mean, these are very interesting things. A lot of people say, like, how would we get past the whole thing with, it having 38% the surface gravity of Earth, and you still see we were talking about this before, but having, people on the ISS, they still, even though they work out like crazy, they still experience atrophy.
Yeah, and I mean, it's amazing how many of the side effects of being in space the astronauts are able to work through, right? They're able to deal with their muscles atrophying, the strengthening of their bones, a lot of this stuff. But there's a few that they just can't fix. There's like you have problems with your vision, and fluid redistributes in your body.
Oh,
and
yeah.
there's nothing that you can do to stop that without gravity.
Yeah, and your heart having to pump at a certain rate, generating a certain pressure in order to get blood to your brain. I imagine that would even be different.
Yeah, I mean, I don't remember the exact specifics. Essentially, NASA identified like 11 different changes that happen to your body because you're in microgravity, and 8 of them they're able to either fully or partially prevent with exercise and nutrition and various things that they do on board the station, and 3 of them they can't fix.
3 of them they can't?
Cannot, yeah.
And wait,
Yeah.
where were those? Did you list those?
One was vision, so
Right.
you get sort of a weird pressure in your eyes. One is fluid redistributes around your body,
Mm-hmm.
and then the other one is your balance system, your vestibular system.
Mm-hmm.
That gets affected, and over time you lose sort of a situational awareness of where your body is.
I hear that one's really important because even people that like ride amusement parks, some of people actually die because that gets messed with certain rides. I was actually talking about this recently with somebody because I was curious about like amusement parks. Like, it's not necessarily the danger in and of the design or whatever. It's actually what it can do to the human body. As far as like, destroying someone's like equilibrium.
Yeah, well, one of the things that's really interesting, and this is sort of one of the ideas that NASA has been testing, is it possible to train yourself to deal with those kinds of, rotations and such? And so they actually did a test where they had these chairs that spun around,
Mm-hmm.
and they put people in these, vomit chairs. And they would start at a certain RPM, and then they would speed them up every day over the course of 30 days, 50 days. And by the time they were done with it, people could just handle more and more and more of this. It's kind of like you can cure yourself of seasickness. You can make yourself resistant to seasickness. And so, in the past, the thought has been, if you want to provide some kind of artificial gravity on a space station, you need something that's like gigantic and is spinning at one, to provide one Earth gravity. But what you could actually do is have something that's very small, maybe just a couple of meters, something that could even fit, say, inside the fairing of a Falcon 9 rocket, and it would just spin around. It would be this tiny little centrifuge that you would sit in. It would go fast,
Right.
Maybe 10 RPM, 15 RPM. So it'd be going around pretty quickly, and you would lie down or even stand or sit or ride a bike while it's happening. And it would start by making you sick, but eventually it would make you would become sort of fine with it. It would never be fun. I think you would always feel pretty bad.
Yeah.
But if that could sort of stop those downsides that I mentioned, and maybe you spend an hour on the spin bike every day, or maybe you have to spend 3 hours, or maybe you can just sit and watch
machine.
TV. Yeah. And so this is an idea that's pretty exciting, and sort of NASA and ESA and stuff, they're working on some technologies like this. And there was a bigger one called Nautilus-X that was developed for the International Space Station, and they never built it and they never put it up there. And it was going to be like one that was going to be a few meters across, like maybe 5 meters across, and would spin in this ring. And so they'd stop it, and the astronauts would go inside and they'd all lie down for bed, and then the thing would spin up and they would sleep while they were spinning in this thing. And then it would, when it was time, they would stop it, and then they would come out, and then they'd go from there. So that's an interesting idea. It really feels like it's kind of the next big unknown with space exploration, which is, we know exactly how quickly the human body runs down in microgravity. So now the question is, what are the ways that we can try to offset that? And it doesn't have to be, we always imagine that gigantic rotating space station from 2001, but maybe it can be something really small, and it's only, and just like riding an exercise bike, you're just trying to prevent that that zero gravity, your bones from softening and your eyeballs from popping out of your head.
Yeah. And one of the things, I know this sounds kind of weird, but I don't know how much they've been testing this because I don't see any news on it. But as far as like the journey there, so the journey there would be roughly 8 months, right? Mm-hmm. And, you know, putting people on, you know, I know people can get along, like on the ISS, people go up there all the time and it's very, you know, it's pretty cramped. But, you know, I mean, as far as, you know, do you think they're going to be doing like screenings of people
and like space madness?
Right. Because I do wonder, you know, if it's not left to what we would consider the professionals, which we have right now, if we start having these missions where, you know, just like your everyday Joe, maybe like me or like Joe. But, you know, like how would they, because I could just see it unfolding, you know, we have space news.
I mean, this is to have human beings be in a cramped environment for long periods of time where it's dangerous and they have to rely on themselves. I mean, that experiment has been done. That's submarines, that's Arctic research stations, that's explorers who are on boats back, you know, turn of the century. So I think
that's good, but those are trained people, you know? I mean,
well, for sure. No, and you're going to want people to be trained if they're going to do this, right? But when you look at, say, the BFR, it's going to be pretty big. It's going to have room for 100 people. It's going to have gymnasium, cafeteria. It's going to have separate bunks for people, common room areas, and all kinds of facilities on board while people are making that trip. So I don't think, I mean, it's definitely something that they're going to want to be concerned about.
Yeah.
But I think the risks of space madness are much less than these other sort of long-term risks, which you just, you know, how do you stop these issues of microgravity and galactic cosmic radiation,
right?
And massive solar storms, which can kill you in a day. Right? These are all challenges that there aren't simple engineering solutions for. So,
and have they even really like gone into you know, ideas about how to combat cosmic radiation?
Well, it's right. So when you're out in space, there's 3 kinds of radiation that you have to be concerned with. There is trapped radiation. This is the one that we have in the magnetosphere. You know, this is the Van Allen belts. Like, how do they get through the Van Allen belts? It's the trapped radiation that's around the Earth and it's around Jupiter. And this is the least of the radiation problems in space because you fly through the Van Allen belts in an hour,
right,
2, and you're done. And you go up and over it, and you avoid the bulk of the Van Allen belts, so it's not that dangerous. The second one is this radiation that comes from the sun, the solar wind, and there are times during very bad solar storms where the protons streaming off the sun is lethal, but they're lethal, but they're not that bad. I know that sounds crazy. So you can hide behind shielding. You can put water around you. You can, you can take preventative measures to minimize the impact. And this is one of the things that NASA is planning, is to be able to. I think we talked about this last week, right? They're going to build a fort inside the Orion capsule to try and prevent it. And then the big one is this galactic cosmic radiation. This is these high energy particles spun up out of supernovae and quasars that have traveled billions of light years to destroy your DNA. And there's not really easy ways to prevent against them apart from having some water, some rock in front of you.
Yeah.
So,
because that's not on my arm. That radiation is not on my arm. It's not a part of the EM spectrum.
No. I mean, it's particles.
No.
It's ionizing particles that are going to knock chunks of your DNA loose.
Yeah, and it's
like a bullet.
Yes. This is worse than gamma. I was just trying to say that because I don't know if a lot of people know. I don't know if anybody ever has asked me why it wouldn't be included there. That's why I was kind of trying to lead into that in case anybody had
Well,
that
because
question.
I mean, it's not in the electromagnetic spectrum. They're particles, not part of the EM spectrum.
Right. Well, yes. I was just curious if anybody was curious about that. Anyone mind if I post a link to an interesting I found on Reddit the other day? Sure. You're fine. So there's something else though too. So I didn't get to hear it. But I guess it was it yesterday that they had a teleconference at NASA about
Asteroids.
Yeah, near Earth objects.
Yeah. I haven't watched that yet.
Me neither.
So I actually don't know what they announced.
Yeah, I was looking for it. It's probably on their YouTube.
Yeah, but I think, I mean, the gist is it's not that they have found any asteroids that are dangerous. It's just that they're talking about the need and their techniques and technologies for preventing asteroid strikes on Earth. So
yeah, they have a whole PDF document about it. Wow.
Yeah.
Wow. That is going to be a read. But it says that the plan establishes 5 overarching strategic goals to reduce the risk of NEO, so near Earth objects, guys, impacts through improved understanding, forecasting, prevention, and emergency preparedness. The plan will enhance NEO detection, tracking, and characterization capabilities, improve NEO modeling, prediction, and information integration. I don't have my glasses on, so this is tough. Develop technologies for NEO deflection and disruption missions, increase international cooperation on NEO preparation, and establish NEO impact emergency procedures and action protocols. That's the 5 things.
Right. Yeah. And I mean, they're going to try to detect them. They're going to try to sort of locate all of the asteroids. They can have a better way of, if they do find one that's on some kind of collision with us, to be able to alert people here on Earth, and down the road, hopefully be able to actually change their orbits. So if we do detect an asteroid that's going to strike us years down the road, maybe there are various techniques that can move them out of the way.
Mm-hmm. Yeah. And I haven't heard, I've heard a few different things, but I don't know which ones are really real methods of if there's an asteroid.
Of moving asteroids?
Yeah. So Dr. Pamela said you can paint them.
Yes. Yeah. There's a whole pile of ways. And part of the problem is that we don't know which are the best ways. So now, obviously, the one that everyone thinks is the way is you throw a nuclear missile at it and it detonates and it blows up the asteroid and you're done. But the reality, of course, is that a fairly small space rock can happily eat up any amount of energy that puny humans could throw at it. And in the very best that we could do is break it up into chunks. And then the chunks would all come raining down. And so instead of having, say, 1 city get hit, you would have 5 cities get hit. So but nuclear missiles aren't a completely terrible idea, because when you detonate a nuke right off the surface of an asteroid, you're going to vaporize a chunk of the asteroid itself, and that's going to provide a thrust. So it's kind of like you're turning a part of the asteroid into a rocket by blowing up a nuclear weapon right beside it. So that idea still has potential. It's probably one of the better ones, especially when you consider that Earth has nuclear arsenals right now. There are ICBMs ready to go. In theory, they could be adapted to follow a trajectory that could go out into space. Although, a lot of the ICBMs, they're designed to take a nuclear payload on a ballistic trajectory from point to point on Earth, not to go to escape escape Earth and intercept an asteroid, 10 astronomical units away. So in theory, that's a way to do it. But as you're saying, so as Pamela probably said, you can paint them. So you paint half the asteroid white, and the light pressure from the sun pushes on it and pushes it into a new orbit. And that might do, if you had enough time, that might do the trick. And then there's all kinds of other crazy ideas. Like you do what's called a gravity tractor. So you take a spacecraft, you put it in orbit around the asteroid, and it has like an ion thruster on board. And then every time it goes to one side of the orbit around the asteroid, it fires its thruster a little bit. And so what happens is it's trying to sort of change its orbit around the asteroid, and its gravity is pulling the asteroid while the asteroid is keeping it in orbit. And so slowly it will be moving the asteroid with its gravity. And the price it has to pay is it has to use fuel. The other ideas that I've heard are like a big airbag. So you just like, you have this spacecraft that has just blows up this great big airbag and then bonks against the asteroid, and then it bounces back and then it fires its thruster, it bonks against the asteroid, just does that over and over and over again, slowly changing the trajectory of the asteroid over time. You can put a rail gun on the asteroid. So you just like mount a gigantic gun, a cannon on the asteroid, and then you harvest chunks of the asteroid, load them into the gun, fire it off, and the asteroid will get a kick in the opposite direction while these payloads are being blasted off. And of course you could send them back to Earth, and we could enjoy the, all of the metals and minerals and harvest them. So the more time you have, the more ideas that you have to play with. And that's the goal of all of these programs, is to find an asteroid as far in advance as you can, so you then you've got the time to use all these different techniques as opposed to hide underground.
Oh yeah, we were talking about rail guns yesterday.
Yeah.
Yeah, so everybody was talking about, you forgot about the drilling. Yeah, we didn't mention Bruce Willis.
Yeah, Bruce Willis. Yeah, that's what you need. You need to put a minigun on the space shuttle. That's what Space Force will do.
Right. So that's a good segue into it.
You're going to make me talk about Space Force, aren't you?
Because I stay away from that right now, just because I hear it from everybody else. So
yeah,
that is one of the things that for my mental sanity, there's a tap out point that I have where I have to kind of keep myself in a snow globe and then, choose to leave the snow globe when I can. But yeah, so maybe people don't know about Space Force. You want to?
All right. I guess
it's not a movie.
3 months ago, Trump announced he was at a press conference. He was speaking in front of a bunch of military people, and he said, "I think we should build a Space Force. It's a really good idea. A 6th branch of the military." And then sort of we all reported on it. And then 2 days ago, it came back again, or Monday. Yeah. And so he made another more official announcement during the 3rd meeting of the Space Policy Council, which is this group of astronauts and politicians and scientists that have come together to sort of help figure out what the United States future policy with space is supposed to be. And one of their big recommendations that they wanted to talk about on Monday was the problem of space junk, which, when you look at things like SpaceX planning to launch a constellation of satellites, it's going to have 12,000 communication satellites providing everyone on Earth internet. There are some space junk concerns. So this was sort of one of their big priorities to think about. And so, but instead of commenting on that, Trump kind of doubled down on his plans for Space Force, which is essentially, the way he described it, is a 6th branch of the military. So you've got the Air Force, you've got the Navy, you've got the Army, and you would have the Space Force. And that would sort of handle all of the United States operations in space. But the thing is that the United States already has a Space Force, right? It's the 45th wing of the Air Force, Space Command. They've got dozens of reconnaissance satellites, the GPS system. They've got anti-satellite weaponry. They've got their own space plane, the X-37B. They have in the past launched their own space station to test that out. They've sort of come up with ideas about kinetic weapons that would, and various sort of satellite killing systems, laser systems that would go into space. So you can feel pretty safe to say that space right now is as militarized as possible, right? The only thing that there aren't, we hope, is nuclear weapons in space. And this is because of the Outer Space Treaty.
Right.
So, to say, oh, I'm going to make a space force, the obvious point here is that there already is a significant space force, and they are, there aren't nuclear weapons, but there is absolutely gigantic levels of militarization of space. So then the question is, what's the plan, man?
Right.
Is this an org chart change? So you take all the people who used to be part of the space command in the Air Force, and now you have a new branch of the military, and you put a new general in charge of it. There's a 4-star general in charge of Space Command. Is he now a 5-star general in charge of Space Force? Who knows? So really, right now, because there really is so much militarization of space already, I'm at a loss to imagine what they might do beyond shifting up their organizational chart, right? Like, it's not like there's a need to build space fighters and space dreadnoughts and all that kind of stuff. Maybe down the road, when there's going to be mining on the asteroid belt and a colony on Mars and space pirates, then you can imagine a need for a space force. And it's inevitable. Like, it is absolutely inevitable that when human beings are out there and they have various investments in other worlds and other planets, the military is going to come along for the ride, because that's just what human beings do. So right now, I can't imagine anything that Space Force would be that it isn't already.
Right.
But if someone wants to provide some kind of announcements, I would love to hear that. Like, one of the things that's crazy is, Trump said to open up NASA or to unblock NASA. But I mean, NASA has been begging for higher budgets for decades.
Right.
To be able to fulfill the priorities that have been given to them by Congress. And like, this is like the first year that NASA has gotten like a really good budget.
Right.
So Congress delivered. They gave them a really significant budget this year, a really good budget for planetary exploration, potentially more budget for human exploration. So that is how you sort of unblock NASA, is you give them the budgets to fulfill the priorities that you've given them. And this is why plans have been canceled in the past. Is, you look at what happened with, George H.W. Bush was going to go to Mars, and then Clinton was going to go to Mars, and then W. Bush was going to go to the moon, and then Obama was going to go to asteroids.
Right.
The plans change. So.
Yeah. And so some people are asking here, someone asked in like a very short, where was it? There was a few people asked the same question. It was Zeror. I don't know if I'm saying that right. Will the Space Force allow more money to be directed into space science? And you just kind of answered that.
Yeah, I mean, whenever there's money spent on military, especially wars, there are scientific benefits. So is that our preferred way of getting science? I don't think so. Right. I prefer you spend money directly on science if you want to get science, but there are absolutely side benefits that happen from that. I mean, look at the GPS system, right? Yeah. That is the handiest part of your phone, that it tells you where you are, is a military system that was developed for by the Air Force, for them to be able to coordinate activities, and now we all get to use it. So yeah, even us Canadians. So I think that there are absolutely, and there would be hardware and various kinds of developments and research that could get done that would have benefits as well. So again, until we have any actual details about what's actually being planned, we can't really provide any analysis on what's going on.
And so just to ask the questions in case other people might not know, what is Trump's, what's his fascination with the moon? So he wants to go to the moon and Mars. right?
Well, the moon, then Mars.
Then Mars, right? Moon first, then Mars.
So the plan right now is to build the deep space gateway at an orbit that sort of takes it close to the moon, staff that up, and then start making, getting humans back onto the surface of the moon, and then use that as a jumping off point to be able to go to Mars. And that's not a terrible, that's a perfectly fine, very reasonable way to approach space exploration. Right.
Yeah. Do you get asked a lot, like, what are your opinions on it? Like, which one do you support more than the other, Mars versus the moon?
I don't know if we've mentioned this in last week. My personal preference is to go with a capabilities driven model. So, so essentially you don't pick any specific target. You don't say, we're going to the moon, we're going to Mars. All you do is just keep trying to do better than you were able to do before. So just if we can have a human being survive for a year, let's try and have a human being survive for 2 years. If we can survive in low Earth orbit, let's try a high Earth orbit. If we can, let's try and practice growing food in space. Let's try building more complicated materials in space. Let's try harvesting more energy in space. Let's try, you pick a bunch of sort of overall ways to measure your ability, and then just try to improve them all, because all of those things will be valuable to exploring anything in space. And that way, if the goal changes, it doesn't matter. We're going to the moon. Okay. We're going to asteroids. Sounds good. We're ready. Right. That's my preference. But I do understand that for a lot of people, that they find that goal really, they find that goal really inspiring. But at the same time, I think a lot of the skepticism and cynicism that's come in now is because the target has changed so many times that everyone is kind of like, I don't think anything's going to happen ever.
Yeah.
Space sucks, right? How come we never went back since Apollo?
Yeah, that was also, those missions were war driven too, going to the moon in the first place.
Yeah, well, going to the moon cost, I think, 10% of the Americans' budget. Now it's 1/5. No, sorry, it's now 1/2 of 1% of the U.S. budget. So they went broke going to the moon, and they bankrupted the Russians trying to keep up with them.
Wait, I'm sorry. I'm trying to filter these messages too. Some of them I can only get like halfway through. And I'm curious though, obviously mining an asteroid is currently, mining an asteroid currently is excessively expensive and not all worth doing. What needs to be done to decrease the cost and make it worth considering?
So there's a couple of companies right now that are actually working on practical asteroid mining. One is called, Deep Space Industries, and the other one is called, oh my god, why don't I have this in my brain right now? I just did that. This is the problem. I'm working on an episode about this, and so it's out of my head. So Planetary Resources, that's it. And they're both kind of going with some different approaches to it. With Planetary Resources, they've already launched a tiny little CubeSat called Arkid-6, and they're going to be sending another CubeSat to asteroids very soon, within the next couple of years, and they're going to start mining and mapping out the minerals on these asteroids. And Deep Space Industries is going to be doing the same thing. So within the next decade, you're going to have multiple spacecraft that are analyzing the minerals on asteroids, around the Earth. And the folks at Deep Space Industries have built this really cool water-based rocket. So it will refuel itself theoretically from a refueling station or even a comet or asteroid, fill up its tanks, and then it can sort of heat up the water to a really high temperature and then blast it out with steam and be able to, so it's essentially, as long as it can get more propellant, it can just keep going forever with a very easily safe resource to get its hands on. And then there are technologies to actually extract resources, to be able to bring them back to Earth. There's some really interesting ideas on how to construct things in space. And it's one of these things where once you start this ball rolling, there's so many resources out in space. There is enough. Oh, and someone had said there's something like there's enough resources to make everyone on Earth a multi-millionaire. Like the asteroid belt will make us all rich. It collapsed the economy, but yeah. There are more. There's more minerals. There's more, say, platinum in a single asteroid than has ever been mined on Earth. So that's where the money is. And once people crack this, you're going to see this, it's how everything works, right? It becomes exponential. One tiny little probe leads to 10 mining machines, leads to 1,000 mining machines. And so it's going to come on really quickly and surprisingly fast. And it is going to pay for the next stage of exploration of the solar system, because it's, the economy is going to be doing it.
That's interesting. Everybody's like, now we're talking about, because we don't really talk about mining asteroids. I don't really get into that. That's a good topic. I don't know what kind of technologies they have out there or plans that they have for it.
My next video is all about this, but Chad's working on it right now. But yeah.
Well,
yeah,
that's
it's
cool.
all about in situ resource utilization. So how to live off the land in space.
I see.
Yeah.
Total Recall next movie. Spoiler. I know everybody's like, spoiler. Well, no,
spoiler alert.
But that's kind of cool.
I can read out the script to you now if you want me to act out the give you an advanced version of what the episode's going to be. No, just wait. It'll be out in a couple days.
I was going to be like, people are going to say they want that. They're going to say it. Do it. See, do it.
We used to do that, actually. We used to, when we were rehearsing, we would do like a live stream on Instagram, I think, or, and we would just do a live, like a Periscope, and just do a live rehearsal. And then people would tell us if they found any problems, and it would give me a chance to practice before we actually went and shot the episodes.
Yeah. That's actually going to be really, really cool. And you guys know there's thank you, Joe. Joe's amazing. All of his information is there too, so you can see when he posts that stuff. It will be on on his YouTube.
Mm-hmm.
And
I had an idea. If you're up for it, I was thinking we should do a crossover where we do a live stream at the same time. So you stream it to whatever this thing is,
Twitch,
right? And I'll stream to YouTube, and then we could put the chats up at the same time.
Oh, yeah.
And then they could almost like talk to each other through our combined live stream. And,
I wonder if that would be okay. I would have to check with I don't, being like a partner. I don't know if anybody, I don't think I have any partners.
I don't know, because it would be you would be streaming it from your computer, and I would be streaming it from my computer to YouTube. And it would be this weird creature that would be, a different version of the same event, right?
Yeah,
so,
I guess as long as it's not, I have to see, but I don't think that wouldn't break TOS as far as.
Yeah. I don't know. It was just an idea that I had. Which
that would be really interesting because, gosh, I don't know. I don't know how brutal the YouTube crowd is. I'm very, used to a lot of the Twitch crowd, and I mean, they're very different. Have you noticed that they're very different in communities, I guess, as far as the platform is concerned?
Our community on YouTube is great, and you can't have a farm without a farmer,
right?
So but they're wonderful. No, I really enjoy it. Like, it's weird because normally YouTube is terrible, right? Like,
yeah.
So but the community on YouTube now is great. They're wonderful. We have a really good time talking, and it's the same thing with you, right? Which is that people start out and they're like, "What is this?" And then they put up the Kappa emoji and talk about flat Earth. And after a while, they have some questions for you, and you sort of fall into these various memes together, and so you have it becomes a family. And so it's the same thing for what we have over on YouTube.
Yeah.
And it's about the same number of people, right? I get whatever, 200, 300 people watching live when I do my live stream. So anyway, it was just an idea.
No, that is really good. I would have to make sure, because again, like it's different with being like partnered, and being partnered, they can, be interesting about that. And I'm not sure. I mean, it's a good question to ask. And I think that would be a really cool idea, actually.
Kappa Ranger says, I probably don't even know what a meme is. And the hilarious thing is, pretty soon when the new copyright laws go in, nobody will.
Yeah. So. Fraser knows what a meme is. Fraser's OG. Fraser's been a part of this stuff for a long time.
Yeah.
But yeah, because I do notice like your community is, more amateur astronomers. I have a lot too, and actually a lot of people have come over here, and they're great. But it's definitely a different dynamic. But that's also because I'm like the crude Carl Sagan type person. That's what Paul calls me, the crude Carl Sagan.
Yeah.
Yeah.
No, anyway, if there was some way, you ever remember when they had a crossover with, I think it was like Superman and Spider-Man?
Uh-huh.
And they had in a comic book together.
I feel like Spider-Man's been everywhere.
It was like a DC and Marvel crossover, which just
I know exactly what you're talking about. Yeah.
I thought it was great. And so I figured that would be fun if we could figure out some way to bring our communities together and have like a party all at the same time, which would be fun.
That would be fun. And also the telescope thing too. That's something I'd... Gosh.
Yeah, no, and we're going to do another test tonight. So I've got access. I can now I can open up the roof on the observatory, and I can sort of show people a live view of the telescope, and then. But tonight I'm going to do a little bit more training on the telescope, and so then I should have total access to it, and then I can absolutely show up some night and bring the telescope, and we can just do some live
virtual star party stuff. But
exactly. Yeah. So if people want to see some stuff in the night sky, we can just run this telescope and look around and see things.
Yeah. Yeah, virtual star party, hell yeah. Yeah, so he actually did this a while ago. This was a big thing, and so they kind of stopped it because, getting many people on board, like in the consistency of it.
Yeah,
it's tough.
Yeah, it was tough. It was really hard to be able to get all of the, everyone had weather issues, and they were taking their gear, and they were trying to go outside and be able to, live view what they were seeing through their telescope. So it was very much herding cats. And so at this point we figured out a way to make it a lot more stable. So we've always got some gear that we can bring to the table, and then have other stuff on top of it as well. So so my hope, and I've been talking about this for a little while, but my hope is that it's going to be a much better experience this time around, both for the people who are watching, and also the just for like the astronomers as well. They're not going to feel so much pressure. So right, yeah, and then everybody in here has been saying, let's, they want me to do it, but I can't because I've told you about the problems. I have manual. I don't have software, and I just can't remote control my telescope. Right, and so if you do like a late night stream for California, right, which for them, so it would have to be 8 o'clock Pacific time after, then or just do we can just do some like special night and bring the telescope and do some live streaming and take requests. And I think people would love that. I know that they've been really they've wanted that for a long time, and I don't have enough money to go buy. Well, and the thing is that it's more than that, right? It's about having the telescope in a location that is clear skies, very dry. Right. It's about having the gear set up in a way that you can control it completely automated, and to be able to. And so the telescope that we've got is this really special telescope that is designed for doing these live streams. So it's designed to take a really fast picture of the night sky in color, in full color, which for most people is worthless.
Right.
But for what I want it to do, it's going to be perfect. So
Yeah.
yeah, I can't wait.
I think that would be amazing.
Squeak is saying, 24-hour live stream is different astronomers stream the night sky. That's sort of hopefully that's the plan down the road is we'll eventually have telescopes at various times. So, we could be watching the sun while we're watching the moon or watching the stars at the same time because the Earth is a ball.
Yeah, and if you like, solar telescopes are amazing too. Like, I feel like they don't get enough. People don't really talk about those as much as they do as, just standard telescopes that we use at night. They don't talk about the solar, and you can have telescopes where you have a filter for, the sun too.
Yeah.
And that's always cool. But yeah, I think, so guys, that would be here. We could do that on a night. We can organize that when everything's, Yeah,
Flow in Pros, it says full color fast exposure sounds very expensive. It is. It's a very expensive setup. It's like 150 millimeter refractor telescope with a really good color camera. So it's going to be a really wicked setup. Yeah.
Someone just asked, and we get asked this a lot. I should make a command for your recommendation. I forget, but what's a good scope? Yeah, I always recommend binoculars first. I always go with try binoculars, see how much you use them. Also, binoculars are great because you can be mobile. Sometimes you can get bigger telescopes that are harder to move. You can still move them, but it's rough toting around my Dobsonian because.
Well, and when was the last time you used it?
The last time I used my Dobsonian would be last fall.
Mm-hmm.
Yeah,
so there's your problem.
Yeah, like in winter, I didn't bring it out at all.
Yeah. So I totally recommend for people that if they think they want to get into astronomy, the first thing to do is to start with is get a pair of binoculars.
Celestron,
and even just like
ones.
regular binoculars, just like
true.
7x35s. It's amazing what you can actually see in the night sky with that. The Milky Way looks amazing. You can see the Andromeda. You can see a lot of really interesting star clusters. The moon looks great. And then from there, you want to go to like maybe a 15x75 or 25x100. And those are, they're more expensive, but they're not that bad. Like say $75 or $100
yeah,
for
you can get the
15.
the 15x70. You can get those for like $60. Those the Skymaster?
Yeah,
like
the
Celestron ones. Yeah,
and so that's pretty cheap.
Yeah,
and then and if you find yourself going out and doing it and actually looking at the sky and you're having fun with that, and there's something really special about just binoculars, like that binocular vision gives you a much better view into the sky than looking through one eyepiece. Then you've got a decision to make, which is, you do need to get a telescope. And the question is, do you want to go the route that Skylias went, which is to get a Dobsonian, which are big, but they're hard to point.
Yes.
So
very.
Yeah. And so you'll like take your telescope and you'll point it at some object, and like say Saturn, it takes you 5 minutes to just find Saturn. And then you line it up, and then you're like, okay, now quick, take a look. And then someone that comes over like, I don't see anything. You're like, oh, it moved. It moved. And so you're like, go and you put it back in the middle, and then you go, okay, look. And but the Dobsonians are great. Like they show stuff off much bigger. It's a much better view. The way I like to go is to go the go-to route. So to get a smaller telescope that has a really nice mount on it that will track the night sky. And a lot of them now are controllable by your computer. You pick your target and then just turn it loose, and it will track to put it into the eyepiece and then hold it while it's tracking, and that's great, and so then you can say, hey, quick, take a look. And for those kinds of telescopes, for a big Dobsonian, $300 to $500. While if you want a sort of an entry-level go-to telescope, you're really going to want to go in the $700 route. But I find if you've got it properly, if you know how to use it, it's just a much better experience. You take it outside, you set it up, and then you start pressing buttons and you start looking at different things and you can observe for the night. So
Yeah.
So I do like the go-tos. Now, where it gets really complicated is if you want to do any astrophotography, and that's when it just gets expensive.
Yeah.
So
Exactly. You got to get those CCD cameras and all that. But
yeah, and so, but I mean, even you should be able to get, like, I think Celestron has their like ETX ones, and they've got like a smaller, like a 6-inch or even a 4-inch Newtonian, but has a go-to mount on it, and you can get those in the 300 range. So that's sort of the that's the kinds of prices that you're looking at. So it's not that bad. And I would go the go-to. I would overspend on the mount and underspend on the telescope. Don't worry at all about the size of the telescope. Worry about making sure that it's a good mount.
Right. Yeah. And again, like, mine is a Dobsonian and it's big, and putting it to the back of my car and driving it places, like, I always get so scared because, mirrors. And
and there's some of these little ones, they've got a really kind of short little mount on them. You can like put them on a tripod, or you can just put them on the ground, and then they'll track, and they're great. So it's, to a certain point, like if you just want to do some quick observing, if you just want to see the moon, you want to see the planets, there's nothing like seeing Jupiter or Saturn with your own eyeballs. Yeah. Through a telescope. True. But that gets, once you've done that, then you're going to want more challenges. So Kappa Ranger is saying Schmidt-Cassegrain are the best way to go. Yeah, I really like the Schmidt-Cassegrain. So that's like the classic Celestron, the sort of the short stubby telescopes. Yep. With the eyepiece out the back. Those are great. Pretty good mounts, pretty good optics. They require some maintenance to what's called collimation. But apart from that, that's why I personally really like refractors. So that's what's behind me is a refractor. It's a 70 millimeter refractor, and they don't require any collimation, and they have a really nice view. Like, I really like lenses personally. But,
well, I was thinking maybe next time you're on here, like next week, we talk about this. If you're, still available for Thursday, that we talk about this, because I think there's a lot of people that might want to know like entry things to get into this and talking about telescopes and things like that, and that are really scared to ask those kind of questions. And I don't have tons of telescopes. I just have a Dobsonian and a refractor. So
yeah, well, I mean, or we do a special time and we'll do some live observing, and we can sort of show some show like just how to get around in the night sky and things like that. So
yeah well, that is the hour.
Cool.
You are free. Thank you so
that was
much
super fun, as always.
Yeah, thanks for hanging out. And guys, you can find him at all the links above. I will be putting all of that in the VOD description too. I'm not done yet, but he's got to go write more stuff for Universe Today.
Yeah, I got to go do my job.
Yep. All right. Thanks
thanks everyone.
See you later.
Guy. Bye.
Let's see here. Jeej.